So today's video is about the exponential form of complex numbers. Complex numbers are just numbers which have a real part and an imaginary part, and they can be written in different ways. The standard form is z is the number, is a complex number, equals x plus I y, where I is the square root of -1. X is the real part, y is the imaginary part. And this can be shown if you put two lines here. One is the x plane, and what this one here is the imaginary y plane. And we can put a representation of the complex number here. That's x and that's y. We can also represent this number in what's called the polar form, and to do that we simply have a line there, and we'll call that line the distance r, and we call this angle theta, and we can work out one or two things. So sine theta is y over r, so y equals r sine theta, and cos theta equals x over r, so x equals r cos theta. So if we write this using these, z becomes, x becomes r cos theta plus I times r sine theta. Which equals r multiplied by cos theta plus I sine theta. And this is called the polar form of the complex number. So we'll write here polar form, and this is the standard. This one here is the standard form. So that's two so far. The next one is called the exponential form of a complex number. Now, to get that, we need to go to Euler's formula, which is cos theta plus I sine theta equals e to the I theta. And you can see here we have cos theta plus I sine theta. So if we swap that for e to the I theta, we'll have the exponential form of the complex number. So we write this again. Z equals, leave the r where it is, and then cos theta plus I sine theta we write as e to the I theta. And that is called the exponential form of a complex number. So three different ways of writing the same thing. So I've just added a paper there to make it a bit bigger, easier to see, hopefully. So an example. If you have two complex numbers, one's called z and one's called w, and that you want to multiply them together, and you're given that z equals 3e to the power of I times pi over 3, and w equals 5e to the power of I times pi over 6. I pi over 6. And the thing you have to do is multiply these two complex numbers together. How do you do it? So Z times W equals, well, Z is this. Let's write it all out so we don't get confused. Multiplied by 5 EI pi over 6. Okay, so now we can say 3 5s are 15. And then we have to multiply this by this. And if we add these indices, it will give us what we want to see. 15e to the I pi over 3 plus I pi over 6. Okay, and so that equals that. Again, equals 15 e. Let's take that I away so we're not confused by it. Pi over 3 plus pi over 6. Well, pi over 3 is 2 pi over 6. Pi over 3 is 2 pi over 6. If we add that to pi over 6, we get 3 pi over 6. Which is pi over 2. So we can write that again, equals 15 e to the power of I pi over 2. Which equals r e to the I theta. So if we compare this form to this, we can see that r is 15 and theta is pi over 2. So ZW equals, let's write it in the polar form, which is r cos theta plus I sine theta. And now we substitute r and theta, and we should get some kind of meaningful number. So equals 15 times, well, cos theta is cos of pi over 2, which is 0. And I sine theta, sine of pi over 2 is 1. So I times 1, which is I. So 0 plus I is just I. So we have 15I. And that is as simple as we can make it. So we'll give ourselves a big tick and a well done. So if we have another problem to solve, this time we're going to do this one. We're going to do 1 plus I to the power of 12. So if we let Z equal to 1 plus I, if it was in the standard form, X would be 1 and Y would be 1 also. And we could plot that. This would be X. This would be Y. That distance there would be R. And we know then that R squared equals, that's X, that's Y, X squared plus Y squared. And X is 1, Y is 1. So that equals 1 squared, which is 1, plus 1 squared, which is also 1. which is 2. So r squared is 2. R is the square root of 2. And if this angle theta is here, we call this angle theta, and tan theta, opposite over adjacent, tan theta equals y over x, which is 1 over 1, which is 1, which means that theta would be pi by 4. Theta is pi by 4. Okay, so we can now write this in the exponential form. Z equals 1 plus I. Z is also, where's it gone here? R e to the I theta. So R e to the I theta, that's Z, to the power of 12. And we can put these numbers into here and see what we get. So R we said was root 2. E to the I theta we said is pi by 4. All of that to the power of 12. Okay, now if we remember that a to the m to the n equals a to the mn, that's quite helpful, because then we can then rearrange these and we get root 2 to the power of 12 multiplied by e to the 12 times pi over 4 times I. I just swap those over. 12 pi over 4 is the same as 3 pi. So we've got root 2 to the power of 12 multiplied by e to the 3 pi I. Okay, so far, root 2 to the power of 12 is 64 times e to the 3 pi I. Okay, so now we're going to use Euler's identity, which is e to the I pi plus 1 equals 0. So e to the I pi is minus 1. So have we got e to the I pi? Yeah, we've got e to the I pi to the power of 3. Minus 1 to the power of 3. Minus 1 to the power of 3 is minus 1 times minus 1 times minus 1, which is minus 1. So e to the 3 pi I is minus 1. So we've got a final simplification of 64 multiplied by minus 1, which is minus 64. And I think we'll give ourselves a tick and maybe a star, a little star this time. Oh, not a very nice star, a star this time.